First thing it's going to ask you is what exactly is a sample space, okay? A sample space is a set of all the possible outcomes in an experiment. An example would be if I was asked for the sample space of 3 coins when flipped upside down. Sample space would be head, 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 tail, 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 head, head, tail, head, tail, head, tail, head, head. Then you're going to have 2 tails, 1 head, so tail, tail, head, tail, head, tail, 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 sorry, head, tail, tail. Okay, now, you can see that's an example of a sample space. All possible outcomes have to be in the sample space, okay? Now, mutually exclusive events. Mutually exclusive events occur when 2 events can't happen at the same time. Okay, so if you're talking about a mutually exclusive event, you can represent them by Venn diagrams, okay? So I'll give you an example, okay? So, sorry, page 25, excuse me. Okay, so a mutually exclusive event, guys. Imagine I had 2 events, A and B, like so. A and B could be an example of, let's say, the probability of pulling a king and a queen at the same time in cards, okay? So this can't happen whatsoever. So do you see the way the 2 events they have no intersection? Because they have no intersection, okay, the probability of A union B, probability of A or B is represented as probability of A union B, that equal PA plus probability of B. Okay, in the case of pulling getting a queen queen out of your deck, would be 4 and 52. A king would be 4 and 52. Add them together, your total probability would be A and 52. It's just basically events that can't happen at the same time. Now, if an event is not mutually exclusive, what happened next, guys? Are you listening? An event is not mutually exclusive. What would happen next is you'd have a Venn diagram, but your Venn diagram would have an intersection. So an example would be pulling out a club card. So that's C for clubs, and let's say clubs and a queen, okay? So what you'd have here is that you'd have the queen of clubs representing 1 card in the middle. You'd have your 12 remaining clubs to the left. You'd have your 3 remaining queens to your right. That's going to be 16 cards out of 52. In this case, for a non-mutually exclusive event, your probability of A or B would be PA plus PB, and you take away P of A intersection B. What does taking away the P of A intersection B do? Stops you from double counting. Stops you from saying 13 clubs and 4 queens, because you forgot to take away the 1 card they have in common. So that prevents that from happening. Okay? Is everybody alright with those 2 definitions? Now, an independent event, guys. What is an independent event? Okay. An event that, let's say event A is followed by event B. Okay? So probability of A and B happening. What's another way of saying A and B in sets language? A intersection B equals PA followed by PB. Okay, to prove that events are independent, if I said, let me see, if I said I have a coin and I have a dice, okay, and I said, what's my probability of getting, I don't know, a head followed by a 6, would be a half multiplied by 1/6. Is that alright? Now these are independent events, aren't they? Because the outcome of the coin does not affect the outcome of the dice. Everybody happy with that? Now I'll give you an example of an event that is not independent. Okay, I have a bag. I have 3 reds, 3 blues, 2 greens. Okay. So we're going to do is your probability of getting a red, okay? So we're going to say the probability of getting a red followed by a blue, okay? So red followed by a blue. So probability of red is going to be 3 in 8, okay? And then the probability of blue will be 3 in 7. But you can see that this event isn't independent because the outcome of the first one will affect the outcome of the second one. Because by removing one of the items, okay, it reduces the amount of items in the bag, which affects the probability of the second one. So this event like this isn't independent. Is that right? Okay, cool. Now we're going on to this one here. In a class of 30 students, 20 study physics, 6 study biology, 4 study physics and biology. So that'd be 4 in the middle, right? And then 16 left over, because 16 plus 4 is 20, and then, what is it, 2 here? And 30 students in class in total, which will make that 8 on the outside. Okay. A student is selected at random from this class. The events E and F. The events E and F are: E is the student studies physics, F is the student studies biology. By calculating the probabilities, investigate if the events E and F are independent. How do you prove they're independent again? F equals PE multiplied by PF. So P intersection, that's 4 in 30. Would everybody agree with that? 4 in the middle out of 30. What's the probability of somebody studying physics? 20 out of 30. Probably somebody studying biology? 6 out of 30. So that is going to be, what's 120 divided by 900, anybody? I think that is 4 and 30. I think they're going to be equal to each other. So 4 and 30 equals 4 over 30. The events are independent. So what we have here, guys, is that the results are independent because it obeys the law for independent events. Okay, so you can say hence they're independent. Moving on to question 2. A random variable x follows a normal distribution with mean 60. So you're talking about mean 60 being here, and a standard deviation of 5. Find the probability that's less than 68. Straight away, the answer is over 50%. Why is the answer over 50%? It's right off the mean, which means it's got to be over 50%. Everybody got that? Second thing, you find out your Z score. Z equals your number minus your mean, which is mu, right? X minus mu all over sigma. This is the bargain basement one, okay? So Z equals 68 minus 60 all over 5. Z will equal 8 over 5, which is 1.6. You want to find the probability of Z being less than or equal to 1.6. Okay? You can just read that straight out of the Z score tables, can't you? And when you read that straight out of the Z score tables, you will find that it's 0.9452. Is that alright? Find the probability of Z score in between 52 and 68. So if we modify this, now, so guys, this is 52 here. Now, something I'm noticing between the two of them is that the 52 is equally distant from the 60 as is the 68. Don't think it'll affect how we're doing it, but I say one of them will be the plus Z score and one of them will be the minus Z score. So we'll just find out for sure. Z score equals 52 minus 60 all over 5. As predicted, it's the minus version of the last Z score. I now have to find this green region in here, okay, in between the two scores. So what we're going to do is we're going to change this question into P of minus 1.6 less than or equal to Z less than or equal to 1.6. Is everybody alright with that? Okay, now I'm going to look at this, and what I'm going to try and figure out first is that if I, it's going to be 100 take away these two areas here. Would everybody agree? 100 take away the two red areas. The red area is bigger than 1.6 and the red area that's smaller than 1.6. Would everybody agree they're the same size as each other? Okay, so if I use the answer from the last part, remember my 0.9452? My 9452 was everything smaller than 1.6. Agreed with that? So if I take that score away from 100, I'll find out one of my red areas at the end. So 1 minus 0.9452 gets me, anybody? Anybody? 0.0? 0.0548, okay? Now if I double this, because the two red areas are the same, what happens then?
Then you get both areas.
I get the area of both red areas. So double it. 0.1096, okay? I want the green area because I want the probability in between the two scores. 1 minus 0.1096, and what do we get? 0.8904. Okay. Okay. So the heights of a certain type of plant when ready to harvest are known to be normally distributed with mean U. The company tests the effects of 3 different growth hormones on these type of plants. So they're usually normally distributed, and we're going to see does the effect of the hormones shape that distribution in any considerable way. Okay. The diagrams A, B, and C on the next page show the expected distributions of the heights of the plants at harvest time without the use of hormones. The effect on plant growth of each hormone is described on the next page. Sketch on each diagram a new distribution to show the effect of the hormone. Okay, just give me a second. So there's a diagram A, diagram B, and diagram C. Now what does it say about the hormone again? I'll just go reread that question again. They seem to be. Okay, oh yeah. It tells you what the effect is to the left. The effect of the hormone was to increase the height of the plants. Okay, if you imagine this to be 80, just call it your old mean was 80 centimeters. However your new mean is, let's call it 90 centimeters for argument's sake. We're assuming that our growth hormone has made all the plants bigger, but hasn't affected the distribution of the sizes. So it's like a human growth hormone. Somebody that was 6'8" will now be 7 foot. Somebody who used to be 5'2" will now be 5'6" or 5'8". It doesn't affect the shape of the distribution, it just affects where it's located. So if everybody gets bigger, there'll be a new distribution, and it says that so there'll be a new distribution, okay? So the most common height will be 90. It doesn't actually affect the height of the distribution. It just says that the new most common height will be a bigger height than previously, and it'll go back down again. So see the peak of the distribution. That just means the most common height. So all I'm arguing is that if the old most common height was 80 centimeters, if we increase the height of that distribution, the new most common height, let's say for argument's sake, is 90. So it'll just shift across the shape of the distribution just a bit to the right. If I was to shrink the average size of the plants, what would happen? Just for argument's sake, it'll be to the left. Same distribution to the left, okay? Now, the effect of hormone B was to reduce the number of really small plants and the number of really tall plants. The mean was unchanged. Alright, less people, so I'm redlining here. This red line is the amount of small plants, yeah? The amount of small plants is now smaller than the black line previous to it. The amount of average plants increases, and then just narrows the complete distribution up. Because you have a higher amount of mean heighted plants, but the extremities where you had like a really big plant are a lot smaller. So it's less common. Does everyone understand that the height of the line just means how many people have that height? It's not actually the height. Is that alright? Now question C. The effect of hormone C was to increase the number of small plants and the number of tall plants. The mean was unchanged. So what this does is you have more small plants than you used to. So it'll be up here. Okay, because there's more of them. You'll have less average height plants. And then you're increasing the amount of tall plants. It'd be like that. More tall plants and more small plants. therefore your average number has to go down. People who are average sized or plants that are average sized are less common. Is that right? Okay. Okay, guys. So what we have here is we have Go Fast Airlines provides internal flights in Ireland, short haul flights to Europe, and long haul flights to America and Asia. On long haul flights, the company sells economy class, business class, and executive class. All passengers are allowed to have a baggage of 20 kilograms and must pay an extra and may pay a cost per kilogram for any weight over 20 kilogram allowance. Each month, the company carries out a survey among 1,000 passengers. Some of the results in the survey for May are shown below. So they basically tested more women than men. Then they gave them the following questions. This is how many people answered yes and how many people answered no. Has nothing to do with sex, okay? And this one is would you fly again with Go Fast Airlines? 913 say yes, 87 say no. Then these had the mean age and the median age, so 42 to 31, talking about middle-aged people there. And then spend on in-flight facilities, on average we spend €18.65, and then the middle person spent €32.18. Now what would that tell you about the
Skewed.
yeah, it's skewed, okay? Now what way would you imagine it's skewed? That the median, huh?
Less skewed.
I say there's a lot of I say there's a lot of people to the right dragging the average up, maybe.
No, to the left.
Oh, sorry, to the left. Sorry, you're right. To the left would mean that a lot of people paid a low amount of money. Okay. Now remember what we said about skewness. What gets it? Just 1 second. The mode is never affected. Isn't that correct? And 99 times out of 100, the mean is affected more than the median. Remember we did that question years ago where we had we had like people on an average of was it €50,000, and then we just put in a CEO on 200 grand, and he sent the mean shooting upwards, but the median barely changed. Okay, so that's mean, mode, median. Now let me explain what's going on here. Okay, the median would be the middle person. Okay, and the middle person is higher than the mean. So the middle person would be on €32, let's say. And see the way there's a lot of people dragging the average down by spending low amounts of money. That's what the mean is set further to the left than the median. Alright, who's not getting that at all? Perfect, right? Not necessarily perfect, but we'll explain it another way. Here's what I'm gonna explain to you, right? We're gonna make up a small company, okay? Somebody's on 10 grand, somebody's on 20 grand, somebody's on 30 grand. We'll put two people on 40, okay? And we'll put somebody at 50, followed by 60, okay? What is the average of all these? 30 plus 30, 60, 100, 140, 190, 190 plus 60, 250. How many people do we have here in total? 1, 2, 3, 4, 5, 6, 7, is it? 7, right. 7 goes into that, let's call it 35 times. 35 times remainder 5. 35.5 is roughly the mean, okay? You happy with that? The median is the middle person. Who's the middle person? 40. Would you agree with that? Median is 40. Okay? Now, what happens next is that if I add on a big number at the end, if I add on the bulk, let's say, let's call it a CEO on 200,000. Okay? What happens to the mean? Well calculating, will we all agree that the mean absolutely shoots up? Okay. Second thing, the median. What happens to the median? It's now the average of the middle two, and it actually stays at 40. So that you're showing the effect of basically having a big number at the back sends the mean absolutely flying in one direction, and the median remains the same. Okay. So when we go back to this example here, what we're saying, yes. Okay. So guys, what happens is, okay, on a normally, if you just go to a random I'm going to design two graphs. I'm going to design that's a positive skewed graph followed by a negative skewed graph, okay? Now, this is just money spent, okay? Money spent is on both axes. Would you agree with that? Now, what this means, if I argue and I say that the mode is, I don't know, let's call the mode 30, okay? Would everybody just say, that means the most common amount of money is 30. The mode is always the peak. Would everybody agree that the mode is always the peak of the distribution? It'd be like me saying 200 people spent 30 euro. Anybody who spent another amount of money, less people did that. Okay, so it'd be like 100 people spent, I don't know, 15 euro. Okay, because it's half the height.
So you're saying that more people paid a higher amount for ticket?
Just let me finish, okay? So what we're saying next is that if you're skewed this way, okay, you have lots of people here who aren't as common. Like these people here aren't as common as the people over this side of the graph because there's less of them. But what they are doing is they're spending massive amounts of money. This massive amount of money sends the mean flying over in this direction, away from the middle. In a symmetrical distribution, the mode, the mean, and the median are all located at the peak. However, the presence of these guys, see the way they're skewed positively, see the presence of these guys spending big money sends the mean to the right. And as previously discussed in the last question, it doesn't affect the median as much. Would you agree with that? So it doesn't affect the median as much. So the median would be located here. In the opposite extreme, if we have lots of people spending low amounts of money, a couple of guys spending €1, €3, €5, €7, they just keep dragging, they drag the mean downwards. So the mean gets sent flying to the left as opposed to flying to the right. Yeah, but it's such a low value in comparison to the 30 that it skews the average to the left.
Yeah. But if there's more people spending less money, shouldn't that be still be higher because there's more people spending less money?
Which graph you talk? So what is meant by a stratified random sample? Can anybody tell me? Stratified random sample?
It's in layers.
What do you mean?
Strata or layers.
Okay. The population is divided into different subgroups with common characteristics. Random samples are then drawn from each subgroup according to the proportion of the population. So an example would be we could break people into men and women, that they're different subgroups, and then within that subgroup we can then do a random sample. Or age, we could break them from 10 to 20, 20 to 30, 30 to 40, and then within that group we do a random sample. That make sense?
From each, like a random sample from each group.
Yes.
And then compare it.
Okay guys, so we explained that. Write down 4 different passenger groups that a company might include in their sample. So you gotta go back to the start of the question. So what you say, you might say, you could say short haul passengers, people who are on the short flights. What else can you say? You could say long haul. You could say long haul business class, long haul executive class, long haul business class.
Medium haul.
Yeah. So we basically named them all off, okay? What's the probability that the passenger selected at random from this sample had his or her flight delayed? What is the flight delay statistics? 231 out of 1,000. 231 out of 1,000, guys. 0.231. Not satisfied with the overall service? 238. It's there. 238 out of 1,000. That won't get you full marks because it's not a fraction in its lowest form. So you can just say 0.238 if you want. Was it 264 or 238? 238. Okay. Now, an employee suggests that the probability of selecting a passenger whose flight was delayed and who was not satisfied with the overall service should be equal to the 2 probabilities above. Do you agree with the employer? Okay, I'm going to say no. Okay, now the reason why I'm going to say no is this: there is a chance that somebody whose flight wasn't delayed was also dissatisfied with the service Do you understand that?
Yeah.
That's your argument right there. There is a chance that somebody whose flight was on time, but could still be dissatisfied with the service.
Or the opposite way around.
Or the opposite way around, we're double counting people.
Yeah.
What happens is a lot of people who were delayed also. So what?
Probably would have been service.
Yeah, so just reread it.
Yeah.
Flight suggested probably seeking the passenger flight was delayed and was not satisfied with all should be the product. So you're multiplying the two of them. You're treating them as independent events.
And they might not.
So they're not independent, okay? So no, they're not independent events. Is that alright? Cool. Which of the graphs below do you think is most likely to represent the distribution of weights of passenger bags? So, which of the graphs below do you think most likely to represent the distribution of weights of passengers' baggage? Okay. So what we have here is different weights. Now, what do you think is wrong with the first one? If you're a passenger going on the flight and you don't want to go over 20 kilograms, what do you think is wrong with that? An equal amount of people are below 20 kilograms are also above it. So you have 50% of your population is below 20 kilograms and 50% of your population is above 20 kilograms. What would you imagine would happen in an airport? Everybody is trying to get underneath 20. So that would mean it's option 2.
There's not statistics for it though.
Where it's common sense that most people are going to try and get below 20 kilograms. Okay? Maybe I'll go back and see if there is statistics for what you're saying. There isn't. So you're talking about common service that common sense that we've all done a Ryanair flight, and we've all tried to get underneath 20 kilogram baggage. Okay, Grant. I explained that answer there, so no need to go too into it. Draw a sketch of the possible distribution of the ages of passengers based on the data in the survey. Explain your answer. Okay. Now, what do we say we think it is? So we're talking about the age. Okay, because that mean is further to the right than the median. So what does that suggest? What type of skew? Skew to the right, because these minority old people, the old people are in the minority, they're dragging up the age. So what's the mean there? Or so what's the median? I mean, so the mode is always located here. We don't know the mode. The median is 31, which is usually affected less than the mean, and then the mean.
42.
There you go. That is a positively skewed graph where these outliers, old people who are rare going on flights, they're less common, are dragging the mean upwards. Okay, so that's the type of graph we're looking at. The company repeatedly asserts that 70% of their customers are satisfied with their overall service. Use a hypothesis test at the 5% level of significance to decide whether there's sufficient evidence to conclude that their claim is valid in May. Yes, Connor? So guys, what we're looking at here is that a test at the 5% level of significance is basically the 95% test. We're going to try and use p-values here. We're going to get our p-value plus or minus 1.96 times the square root of p, 1 minus p, all over n. Now this is we got to find our statistic, okay? Our statistic is that 600, I think it's 664, I think it's down here. 664 people out of the 1,000 are satisfied. Okay, so we actually had a statistic to use, a proportion if you will. So there we go, we have a proportion. Our proportion is 664 divided by 1,000, which is 0.664. So this 0.664, so we active on the calculator, 1.96 times p, which is 0.664, 1 minus 0.664, all over the square root of 1,000. And what will we get here? Just do this part in the calculator. So 0.664 plus or minus. Okay, so what we're looking at here is 0.0292. We'll just change that to 0.029, okay? And they're both at 3 decimal places now. So we're talking about take that 0.029 away from 0.664. Anybody? I think we're going to get 0.629 away from 64. 635. So 0.635 less than p less than 29 added to that 0.93. So 0.693 when you add it on. Now, what's happening here, guys, is we're saying that in 95%, when we take samples of 1,000 people, 95% of the time, it's going to be in between 0.635 and 0.963. What is our null hypothesis again? Hypothesis test is, null hypothesis is that our customer satisfaction rate is, 70%. And what's the other one? Your alternate hypothesis? Our customer satisfaction rate is not 70%. So what we're going to accept here, or what we're going to say? Null hypothesis is rejected. Reason being, 70% is outside this region. Everybody happy with that? Now, company now makes a claim, okay? Now, I'll show you what the company's claim is. This is important as well. A manager of the airline says that if we survey 2,000 people instead of 1,000 people, we will have the margin of error in our surveys. Is the manager correct? Now, look at this. Our old margin error, our old error was 2.9%, wasn't it? 0.029. Would you agree with that? So using your last question, okay, you'll say that, well, the old survey of 1,000 resulted in a margin of error of 0.029%. We're now going to change the 1,000 into 2,000 and figure out a new margin of error. Anybody tell me what that is? The whole thing now. 0.0207. So you're talking about 0.21. So it's reduced our margin of error. It won't halve our margin of error, but it will reduce it from 0.29 to 2.9% margin of error to a 2.1% margin of error. It should have came out as 1.45% if it halved it, but it didn't. And the reason being is that your margin of error is proportional to 1 over root n. It's over root n. So that's what it's proportional to. Okay? Cool ability. Last one. I think we have a scatter plot, okay? So you might need to help me out with this. I'm going to put age on the x-axis and in-flight. Which one actually needs more numbers? Age goes from 75 and in. So I'm going to put age on the x-axis actually. Okay, it won't affect the answer. Just because I have more blocks to play with. So what's the youngest passenger? 0. Oh, sorry. 18. Okay, but I probably should still go from start. So 0. And how many blocks do I have? 1, 2, 3, 4, 4. Oh, sorry, I count up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25. You know, 25 would be good because it means each block is worth 3. Okay? So that's 75 there, which makes that 72, makes that 78. I think that's the way it works. And now I'm going to go down in 6s because 2 blocks is worth 6, yeah. So 66, 60, 54, 48, 42, 36, 30, 24, 18, 12, and 6. On this one I have 2, 4, 6, 8, 10, 12, 14, 16. I have 18 if I want to, 18 blocks. And how high do I have to go up? 0 to 45, 18. I think each one's worth 3 again. I can't do 2. So 6, 12, 18, 24, 30, 36, 42, 48. So that covers me as well. Okay, label them age on this axis and what's it? Expenditure. Okay, just gonna plot this. Okay, so 46 and 30. So what's 46 is age, isn't it? 46 around here and 30 on the other one. So around there, first one, 29 and 15. 29 being here, €15. Wait, 20, 19 on the age and, oh, so 29 years of age and 15. 15's right there. 37 and 20. Age 37, just around here, and €20. The middle is 21, so just underneath there. Okay, 18 and 0. 18-year-old spent 0, he's a bit of an outlier. 25 and, what's the other one? 10. Okay, 25 and 10 goes around here. 75 and 45. 75 being there, 45 being just here. Okay, 52 and 25. 52, that's 51 slightly, and was it? 25. Around there. 35 and 20. Was it? Age 35. That's 33, 35 and 20. Be around here. And then 40 and 20. Got 38 in the middle. 40 and 20 will be around here. And 31 and 30. 31 and 30. Age 31 and 30. Around there. What do you think? Bit scattered, alright, isn't it? So just to be sure, okay. We go to shift. So we go to stat mode, shift stat mode. We'll do data. We're gonna do our. Now remember, I've changed up my x and y axis, haven't I? I'm saying that the x-axis is money. Once again, it doesn't affect your answer, okay? So my x-axis is money. So will you call me out all the money? Alright, 1 second. Stat mode, two variable. Okay, ready, go for it.
30.
Okay, 30, yeah.
15.
15.
20.
20.
0.
0.
10.
10.
45.
45.
25.
25.
20.
20. 20.
20.
30. Now, it wants me to calculate the correlation coefficient, so I might as well get my figures for the line while I'm at it. Okay, what the other one?
46.
Yeah.
29.
29, yeah.
37.
37.
18.
18.
25.
25.
75.
75.
52.
52.
35.
35.
40.
40.
31.
31. We're doing good, yeah?
Yep.
So then we're just going to shift stat regression. Press our R value for our regression. Now, an R value of 0.88 means there's a lot of correlation. Okay? That's nearly perfect. So what you're expecting is as somebody gets older, they have more money, they can afford to spend it. While you're talking about students when they're younger, generally spend less money because they haven't got their own money. Okay, so as you get older, you tend to have your own money, you tend to spend more. Okay, now unless I graph this wrong, I'm going to find the line of best fit as well. Now, remember we said that y equals we're expecting a positive slope, aren't we? And an intersection around here somewhere. Okay, so let's just see what the a and b values are, just so you can remember. So let's go back to the regression. Stat regression. The a value being 13.87. I doubt that's the slope. So a value is 13.87. I'm expecting a slope around a half or 1 or something like that, somewhere around there. So let's go for the b value. Shift stat regression b value 1.16, call it. Okay. Now, so our value is going to be Our slope is going to be 13, what's it going to be? It's going to be y equals mx plus c, so it's going to be y equals 1.16x plus 13.87. Now, just have a quick look after we draw the scatter plot. Draw a scatter plot, just ask me for a line of best fit. Correlation coefficient 0.88. 0.88. Alright, now what it says is there's a strong positive correlation. Okay, so what can you conclude from complete a scatter plot and the correlation coefficient? I can conclude that there is a strong positive correlation between how old you are and how much money you spend on the flights. Sketch the line of best fit. Perfect, okay. We already have the equation of the line. So when x equals 0, what does the y value equal? So that's 15 is dead center, so 13.87. I'll mark it in blue somewhere here. Pick a number towards the end of your graph, usually a nice round number like the likes of 60. Y equals 1.16 multiplied by 60. Somebody do that in the calculator. Just 13.87. It's actually it's actually going to be out of my graph's range, so I'm going to pick a smaller number actually, like 30. Y equals 1.16 times 30 plus 13.87. Yeah. 48 point. So 48.67 when I'm 30. So looking at 48.67, just a smidgen above 46, and you can see that our line of best fit is actually that line there. Probably means I drew one or two of the points wrong. Yeah. Yeah, your answer in the book has one or two of them off, but yeah. We can you just have to check through your points again, make sure they're accurate. But what won't, even when you're wrong here, what will never lie to you is your equation of your line will always be correct.
Yeah, they see the equation of line are getting marks.
Yeah, it's always correct, and our correlation coefficient is always correct. But what I can make a mistake on is what? The sketch, okay? And we're